Hey, welcome back. Today I'm doing a request. The person asked me if I could design some party favors that are shaped like suckers. It's a picture they saw on the internet. So we're going to go make some 3D printable suckers today. And let's jump into Fusion and do that. So I bought a bag of blow pops and grabbed a blow pop so I could take a picture of it. And so that was me. Here I'm going to insert a canvas here in my new Fusion drawing of my sucker. And let's put this on the front face. Okay, the front face, there it is right there. Okay, and looking at this, I'm going to turn it so that it's upright. Okay, it's upright. Um, um, for sizing on this, they didn't specify what size they wanted, so I grabbed an Easter egg out of the basket and measured it. My Easter egg is 54 millimeters across. That's my Easter egg. Now I want to edit this canvas and I want to center it on the origin. So let's drag it down here a little bit. Slide it over some. So there's my reference image of my blow pop. There are a couple of different ways that you can model this. So one way to do this would be to create a sketch here on this plane. And let's draw a line for how tall it is up here. And then if I press and hold down the mouse button, I can draw an arc off of this line. I should be able to. Looks like that's working fine. So I will go to create arc, 3-point arc here to here. It comes out in the middle. And then L for line tool. Come out a bit, come out a bit, down a bit, back in some, and then I'd like to do my arc again, but the arc went the wrong way. So delete that. Here, arc, 3-point arc from here to about right here, and plop this out. Okay, and then that is then give me a line from here to here. Make that straight. Now you come in here and fidget around with that. Like this will be a tangent constraint to make that, and then by dimension this, we'll give that a round number of 22. Dimension this, give it a same round number as above, 22. And these two should be like identical, ideally. But this one up here, I don't have a line in between this and the lollipop stick. So this is a way to do this. Once you have the sketch, you would come in here and then you would revolve this profile around this axis, and that would make the body of the lollipop. I'm going to construct this differently to show the other way that it can be done now. So I'm going to hit Control Z here, get rid of that sketch or finish sketch, slide this over, and then delete that out of the history. Instead of doing that, I'm going to model this with solids. This is the other way you could do it. Come in here, and I'm going to create a cylinder on, for me, it'll be on the build plate. And eyeballing that, I'm guessing it's probably about 50. We'll bring it up some distance. Let's see if I put this straight on, then I can line these up. Looks like about 21. Okay. Then if I right click, I can create another cylinder and create it on top of this one. Bring it out a little bit further. So the other one was 50. We'll make this one 54. Grab it, bring it up some distance, go to the front again. That's too tall. maybe 28. And then one more cylinder, again, right on the top. This out. And just like the other one, we'll make this one the diameter of it to be 50 and the height of it to be, I think we did 20 or 21. And then we'll do 20 there. Okay. I'm going to keep that 20 number in my head because we're going to need that in a minute. Okay. So next, it's a very cylindrical lollipop. So we come in now and we want to fillet these edges. So I said that that dimension was 20 is what I made that. There's that one. Oops. If I go back and I right click on that and I edit it, I can select this edge as well. Right. And now I have my lollipop. Yeah, it's awesome. What's next? So now that I've got that, I'm gonna wait on modeling the stick. We'll model that one separately here in a minute. Let me turn my canvas off now. So if I was just trying to model this part, that would be perfect. It would be done at this point. But I want to do more than that. I want to make this into something that splits in half and screws together. And when we do that, we have to think about how we want to do that. So I need to choose where I'm going to split it at. So to do that, I'm going to make a construction plane. It's going to be even with the bottom here and bring it up some distance. Look at it so I don't have any perspective distortion. Looks like maybe 24 up would be a good distance. Okay, and now with this construction plane, I'm going to split the body, which is this tool here, split body, or it's also under the menu. Body I'm going to split is a lollipop, and the splitting tool is the plane that I created. Okay. So now I have two separate bodies here. I have the top and the bottom. I'm going to go ahead and click on these and then press F2 or right click them and select rename and rename them to top and bottom so that I know which one is which when I'm looking at the browser tree here. So the next thing I want to do is I'm going to hide the bottom and let's work on the top for a minute. So these planes in the origin are getting in my way. I'm going to hide those. And what I want to do here is shell this part out so that it'll be a specific thickness. So I can set the wall thickness to 3 millimeters here, and I have my wall thickness. So let's see if I can do the same thing on the bottom. Okay. Go back, pick the shell tool, and make it 3 millimeters again. Okay. Now I'd like to be able to look at this part and look at a cross-section view so that I can see these two pieces together. The way we do that, it's called section analysis. We go up to inspect and then section analysis. And the axis will reappear and we pick which plane we want to split this on. So I click that one and flip it around. Now I can see inside that body. So at this point, these two bodies, they are separate and they're still solid too. I'm just, because I have section analysis on, I'm seeing through the inside of them. Now I need some way for these to join together. On my Easter egg that I have, that's done with a simple press fit. And there's a little lip inside it. So I'm going to show how you would do that. So the way that you do that is I'm going to hide the top. No, I'm not going to hide the top. I'm going to hide the bottom and turn off my section analysis. And it's kind of weird there. Let me change the angle that we're looking at it. I need to know, for this purpose here, I need this geometry in a sketch that I can do things onto the bottom. So I'm going to create a sketch on this. Okay. And now I'm going to project in the geometry that I care about. So that's this outer line and this inner line here. Okay. Now I'm going to turn off the top and look at the bottom here. Now I can see those lines. So, great. I'm going to hit finish sketch here. I don't think I need anything else off of this. And turn my section analysis back on. It's hidden here under analysis. Turn the top back on. Now it looks like I need one other thing in my sketch. It looks like I need this line as well. So let me go back and edit my sketch. Okay. And editing my sketch, P for project. I'm going to project in this as well. Okay. Finish sketch. So now I can extrude with the Q command to extrude this line. Now, it may not select the profile. If instead of selecting this profile, if it says here push-pull instead of extrude, then you can turn off the bodies and then select the profile, and it will, that way it'll select the profile, but not the try to modify the existing face. Now that I've got that selected, I want to grab this and I want to extend it up. And I'm going to bring it up. 5 is a good round number. 5 millimeters here. And it's going to join, but if I just leave it set like this, then that is going to weld these two parts together. And let's see what that looks like. So they're back to being just one body again. So instead of doing that, I'm going to come back here and do edit feature. I'm going to unselect the top to hide it, and now it's not going to make it like it's only going to join to the visible body. So there's that. Now I've got this press fit in here, but this is going to slide pretty easily if it fits at all, and that's kind of a crazy idea. But in 3D printing or in any kind of work that you do with machining, there's what's called a tolerance in there. So the parts are never perfect. So you're going to need some amount of space for these to slide past each other, unless you want to put them together with a hydraulic press and they might break. So for my printer, I know for a slip fit like this, I need about 0.4 millimeters of clearance. And the way that I'm going to do that, I'm going to hide the top. I'm into this, and I can shrink this by 0.4 divided by 2, because I'm affecting the radius, and that should give me a little gap. And let's see what that looks like. Do I have a gap in there now? I do. So that's my little gap in there. Now I can hit OK. The other way that I might do this, so right now that's just a press fit, and that would probably be fine for my printer. I know my printer can do that, but maybe your printer has different values for that. So the other thing that we could do, and this is what's on the Easter egg that I'm copying, is we can put a little snap fit in this. And so to put the little snap fit in there, it's a little different. So I'm going to come back and take that tolerance out that I put in there. We'll get rid of that feature. And I need to, I want to do this by creating a sketch here to cut out part of both the top and the bottom. So I'm going to create a sketch here on this plane. And I'm going to, right now I'm looking at a section view. So if I tried to project this in, it would only give me the exterior geometry. So instead I need to hit the S key, and I want to intersect, and intersect this body and this body. Okay. Now if I turn off these, I can see the geometry that's there. And I need a center line here. I'm going to be doing a revolve. So this is the center point. And I'll go ahead and bring that up there. I'm going to make that a construction line. Then these are my existing lines. So I know I'm going to want to cut this. I think, well, let's think about what it should look like. We want to come out from here at so out for line. I want to come out from here, out some distance, and then back into here. Yeah, that works. Now, these two, they should probably be perpendicular to each other to make them and then this angle right here, you know, I don't have to set an angle there if I make these equal to each other. I'll make them equal, and now I can change the size of it. So how far do I want it to stick out? So when I did the shell operation, I said that this outer wall was going to be 3 millimeters thick. So how about 1 millimeter? Here to here, D for dimension, and set this dimension to 1 millimeter. Okay. Now, if I highlight this triangle here, it does line up, or it does light up, and it tells me it's a closed profile, so that's great. All right, finish. Now I gotta turn my body back on. I want the bottom body here, and I'm going to revolve this triangle I just drew on the construction line axis I made. And if I turn off the section analysis, you can see now I've got my little lip that goes all the way around. So there's my little lip. Okay. So right now that is going to interfere with the top. So if I turn my section analysis back on, I can see that there's a line here. So to get rid of that, to make it where they don't overlap, I need to go back and combine these bodies. So modify, combine. The target that I want to do work to is the top. The tool that I want to use is the bottom, and I want to cut the bottom out of the top. So cut is selected here. It's clever enough to figure that out. And then I don't want to get rid of the bottom when I do this, so I'm going to leave keep tools checked. So now if I turn off the bottom, look in here, I have this groove cut in the top. So looking at that, I don't think that's going to work. I don't think that's going to work because this, I have to shove this big V-shaped piece through all of this to get it up there. I think that was way too aggressive in the size of that. Okay, let's come back and let's edit the sketch. Back over here, and I can change, it's kind of hard to see. Let me grab that dimension and drag it out. I can change how far that sticks out. Let's make it 0.4. And now it doesn't stick out nearly as far. Also, it looks like this is really tall. So let me hit finish here, and that cuts it out now. Let's see if we can make that shorter. So if I go back here, let's look and find where I made that little inside lip. Oh, there it is. So I made that way too tall. Let's edit that. Instead of it being 5, let's make it 2 millimeters. Okay. Now I can slide my history marker forward. So I broke it. Now I've got warnings here on these, and my parts have disappeared. Go back. So the last step before the warning is this sketch. And it looks like the reason that it broke there is because these are joined into one body. So let me go back one step earlier. and edit this. And just like we did before where we did the join, I have to hide the top so it doesn't weld the two together. Okay, now let's grab this, drag it forward now. Hey, there it is. Perfect. What if I decided I did not want to have this as a snap fit here though? Well, before I do that, there's one other thing that we should do, and that is the snap fit is neat and all, but it's not going to fit into the top right now, again, because of the whole tolerance thing we talked about. So to fix that, I would come in and I need to hide the bottom, and I need my push-pull tool, which is Q. I want to select this edge and this edge, and 0.4 divided by 2 is 0.2. Oh, that's the wrong direction. Let's flip it the other way, minus 0.2. Okay, now if I turn on the bottom again, you can see I've got a little bit of space in there. Looks like I need a little bit of space here on this cylinder as well. Let me go back and edit that. Turn off the bottom where I can see it. Pick that face. There we go. So that would work. That would give me the a snap fit for this part. Now, this is a pretty tiny snap fit. So go from here to the inside of the cylinder is 2.4 millimeters, but from here to here is 24, 22. So that's 0.4 millimeters on each side. So if you're used to thinking in freedom units, then we think eighth of an inch, quarter of an inch. A millimeter is significantly less than an eighth of an inch. So this is actually roughly one 3D printer nozzle width. So infinitesimally tiny. If I wanted to go back and change that, I could go back and edit the sketch and grab this dimension again, bring it over here. Let's double that to 0.8 and finish again. And now I've got a much chunkier thing. I'm worried though that if I print this, that I'm not going to be able to do this snap fit because there's going to be a pretty significant gap between these. That's going to depend on your printer, and you're going to have to go and mess with that. What if you don't want to have to mess with your print? I'm glad you asked. Let me show you how you do that. So I'm going to grab all of these features that I did here, starting with this extrude. Right click on all of those. I'm going to create a group so they're all grouped together. And now I'm going to suppress this group. Okay? And so that means that all of these are turned off. And instead, I'm going to show you another way to do it. And so both of these will be in the same drawing, and you can figure, or in the same Fusion file, and you can figure out which one you want to do. So I'm going to hide the top here. So I'm just showing the bottom. I'm going to turn my sketch back on. I'm going to extrude that back up again. And let's bring that up 5 millimeters, which is a little less than a quarter of an inch. Oh, it's trying to cut into the part. So let me go instead -5. No, -55. That's too much. Maybe 5 is too little. We'll go 8. Okay. Now I've got 8 millimeters there. If I turn the top back on, you can see that. Maybe I want to thread these instead of doing a snap fit. So to do that, come in here. I'm going to create a thread. And it's going to guess what that thread should be. Check the modeled box. So an M50 by 3 thread looks like it fits in there pretty nice. This might be a little thin. Let's see. We have a bigger, we go bigger. There's 52, but if I look at that next to the top, I think, yeah, actually, I think that works really well. Yeah, I'm gonna go with that. Let me hit the OK button here, but before I hit OK, I'll turn off the top. So there's my threaded version. And just like we did before, I need to cut that out of the top. I'll turn both of them on, modify, combine. My target is going to be the top. My tool is going to be the bottom, and I want to keep that. And now if I turn off the bottom, I can look in here and I can see I've got my cut operation in there. Perfect. So those are those two parts, and I'm happy with that. We'll have to go back and visit our old friend clearance again, though. So looking at this, when you've got threads, you've got a bunch of different surfaces that you can put clearance on. So let me turn the section analysis off and look at just the bottom of the part. So I'm going to use Q to push pull, and I can grab this top face and I can push it in minus 0.2. We'll shrink it inwards, and let's see what that looks like. So turn the top back on, turn the section analysis back on. Now I've got a little bit of a gap here at the top of the thread and no gap at the bottom. Generally, when you're screwing things, or when you're dealing with tolerance in 3D prints, they print oversize. So if I printed this, this part would not actually go together. I need the clearance to be on the underside instead of on the top. So if I go back, I'll want to edit that push-pull again. Let me turn off the top so I can pick my faces. Zoom out, scroll. So deselect that one. Instead, select the bottom face. Turn the top back on. Minus 0.2. Okay, so that works. Now I've got clearance there for that, but I don't have any clearance here on the edge of the two. So turn the top off again and push this one in as well by the same amount. Zoom out. So now I've got my clearance, and that should work. That should do it. I might need a bit more space than this because I only pushed it in 0.2. I made it half instead of a whole. So let's undo one of these. So I'm going to hide the top, and instead of selecting both of these edges, I'm only going to grab this one, which is that face. Hit OK there, and now I'm going to push in this edge 0.4. So that's push pull tool again. Grab him and bring him in minus 0.4. Turn the top back on, pan around. Now I have more clearance in that. Perfect. Awesome. So I'll turn off my sketch. So this is my lollipop. I've got a couple of things that I need to deal with as part of this. So that are left. For this particular thing, use case, the goal is for this to sit on top of a stick and it'll look like a lollipop and you'll be able to put candy in and it's going to be a party favor. So we need a place for that stick to go. Let's turn off the section analysis now. Down here, we're going to put that on the bottom so I can hide the top as well. So I'm going to create a cylinder here on the bottom, right here in the middle. I have to think about how big I want that. I don't know how big it's going to be. And I need to bring it down some distance. So now I need to think about these values that I'm going to put in here. So I don't think it makes sense to print something that is the shape of, that's a long cylinder, that's single use like this when drinking straws exist. I went and I grabbed a white drinking straw out of my, or clear drinking straw out of my kitchen drawer. I measured it 7.3 millimeters. I went to the 7-Eleven and I grabbed one of their drink straws along with a frosty diet Dr. Pepper, and it was 7.4 millimeters. So for me, it makes sense to go get some straws instead of trying to print the inside of this, or print the stick for this to stick on. So if I'm going to make that 7.4 millimeters, then I'm going to need some meat around the outside of that. So let's make the diameter of this bigger than 7.4. So if we add 2 millimeters to each side, that is 7.4 plus 2 plus 2, 9.4, 11.4. Okay. And then for the height of it, I look down at my ruler here. 10 millimeters seems completely reasonable. I'm making this up. 10 millimeters. Okay. Now, you might want to change those values to match your part. So we're going to do something here to make it so that that'll be where you can modify it. To do that, we're going to come up here to modify, change parameters, and hit this little plus sign here to create a user parameter. I'm going to say the diameter of the straw diameter, 7.4 millimeters. Okay. And then the wall around straw, it's going to be some number of millimeters. It's going to be the straw diameter plus, which is 2 millimeters for each side, times 2 is 4. So straw diameter is 4. Okay. So I've got these parameters here. I'm going to hit OK, edit this. And in here, I'm going to make this the wall around straw is the diameter of this part, and the height, we'll leave it to 10. Okay. Now I need another cylinder that lives inside this guy. Create cylinder on this face here, and it is going to be straw diameter, and I'm going to extrude it down into the part. Some distance, we'll say -10. Okay, there's that. When you make a part that's parameterized like this, you have to think about the user doing crazy things. So, come back in here to modify, change parameters. Let's go with something really crazy. Instead of 7.4 millimeter straw, they go to put this thing on a mason jar. Okay. Now this part is floating in the air and doesn't actually bond to this the way you would want it to. So we have to think about how we could fix that for this crazy value. The way that I would fix that is here for this initial extrude. After this extrude, I need to change this and have it be its own body unto itself. Okay. So now if I hide this bottom, I can grab this face with my push-pull tool, bring it down, and bring it down to where it intersects the inside of this. So now that's going down into the inside of the part. If I hit OK, Let's make sure it's still a separate body. It is, and they're overlapping right now. I can tell they're overlapping because there's not a line drawn between these. Let's go back and change our parameter back to where it's something rational. Make sure it doesn't do anything funny. So 4. Okay, that looks great. Now I need to combine these. Modify, combine. Target body is going to be the bottom. Tool body is going to be stick here. The operation now is going to be join, and I don't want to keep the tools. The straw part is going to be solid. Okay. Come back to this last operation here. This is my hole. And did I parameterize that? Did it feature? Oh, it disappeared. Wait. That's weird. It's not letting me cut that now. If first you don't succeed, destroy all evidence that you tried and do it again. So I'm going to create a cylinder here on this face. I'm going to make it straw diameter. Okay. And now we'll cut it in. All right. So let's sanity check. I've got 2 bodies, top and bottom. Let's look at the section analysis, make sure there's nothing weird. It looks like I could have brought that in a little further. Go ahead and bring that in now. Do -10. Perfect. We're almost done with this. Now I need to think about what it looks like to 3D print these parts. So the orientation where I see, or how I imagine this being 3D printed, is sitting flat on the print bed. This one's sitting flat on the print bed like this. And the top, let me rotate around a bit. Sitting flat on the print bed like this. So if I turn my section analysis back on, I have to think about how printable this is. So a problem here is that this doesn't have a whole lot of grip on the print bed. So when you print this, you're probably going to want to add a brim around it so that it doesn't pop off the print bed. Okay. Another problem is this overhang right here. So this overhang, it's not going to want to print because it's at 90 degrees, and most 3D printers can only reliably print overhangs up to about 60 degrees. So I can chamfer this face by some value here. And it looks like if I do 2.1, fine, 2.2, 2.3. Oh, 2.3 gives me an error, so we'll go back to 2.2. There. Okay, so now that is 3D printable. Okay. The other part of this that's not 3D printable without support is here in the dome. So this face, or this angle, we're going to get up to about right here where the dinosaur's tail is, and then we're going to be printing a steeper overhang than the printer can print. I'm going to have to fix that to make it more printable. Lots of ways to do that. The way I'm going to do that is I'm going to create a sketch here on this face. Oh, it's worth noting you don't need to do this if you choose to resin print these, because resin printer doesn't have the same limitations on overhangs. They have different limitations on overhangs, and I am in no way competent to speak on those. Okay? Anyway, I'm going to come up here, and I've started a sketch on this midplane where the section analysis is. And in here, I need to bring in this body. So I'm going to intersect. And the only thing that I really want to intersect is this line, or this inner profile right here. Okay. So if I now turn off the body, I've got these lines. Just like before, I'm going to make me a construction line. In here, see, this should connect to this point, so I'll click both of those, do coincident, and it should be horizontal vertical, so it's straight up and down. And now we'll grab the end of this and drag it up. I made this into a construction line by hitting X, or you can use this button over here. That's done. Now I'm going to make it not a construction line. Let's turn the top back on, view that. So I need to know what a 60-degree angle looks like. Easy enough. Let's do a line here. This. Let's draw another line off of it. Let's go, oops. I hit the F key on my keyboard. Cancel brings that back. All right. So this is what a 45-degree angle looks like. And weird connotation thing here. If I spec this out as an actual 60-degree angle, there we go. There we go. So those are our 60 and 45. I can make these construction geometry. Now I intentionally did not nail this to anything, so I can grab this and move it around. So I'm going to come down here, grab this, and just look at it to see what it looks like. So it looks like I need, if I'm going to do 60 degrees from about there to there, or if I'm going to do 45 degrees, I need to bring it from about there to there. Okay. And I'm going to move this out of the way. L for line. And come here down to here. Oh, and look, it's conveniently, it's got a thing where it's giving me the dimension relative to the line tangent to the endpoint there. So, all right. I'll go ahead and make another construction line here to tangent. So this should be tangent to the arc. Or this could just be horizontal vertical. That would be another option there, I think. Now the angle between these is 45 degrees. Bring this down, and I want these two to connect. I don't know where they're going to connect, but I'll let Fusion figure it out. So I drew a little line up here. You know what? No, I don't want to do that. That would be silly of me. Delete that line. You just bring this down and make it coincident with the arc. So click here, click the arc, coincident. That gives me a little profile in here, which I can select. Awesome. Hit finish sketch. Turn my body back on. Turn my sketch on. Come on, let me see my sketch. There's my profile right there. So I'll revolve that guy. So there's the profile. The axis I want to revolve it around is my center line I drew. And okay. So now this part is 3D printable. I have no qualms whatsoever about 3D printing this. It should be fine. Let's go look at the bottom. Okay, so anyway, so it's going to print like this. Oh wow, that little section right there looks super thin. That's okay. We might look at that here in a minute to make sure it's thick enough. Yeah, let's go ahead and look at that right now and make sure we don't have a problem. So let's inspect from here to the inside. So the radius of the outside is 22.97. Radius inside is 22. Oh, that's only 1 millimeter thick. That's not enough. That'll break super easy. That's just a 0.4 millimeter nozzle. That's going to be 2 walls right next to each other, and we'd like to have 3. I need to make this interface a little bigger. Okay. Click on this interface and hit my push-pull tool, that's Q. Let's bring that out to give us just another wall, 0.4. Okay, that brought that out. Now that's a little bit thicker there. So we got distracted for a minute. We'll come back and work on our, back to making it 3D printable again. So I should probably rename this sketch here. This is the one we just used. This one is the Make 3D Printable sketch. And I'm going to reuse that instead of making another sketch. So it's already on the right plane and everything. So I'm going to edit him. And if I grab, can I move that? Nope, it's not going to let me move it. I don't really need to move them, so that's fine. Intersect tool, again, intersect. And the geometry I care about is this inside of this cone. Okay. Turn off the body. Just like before, going to make a line that goes straight out here. And that's a construction line. Now bring a line down from here to here. And it automatically made this coincident. So you can tell because if I drag it around, it moves. And it stays welded to that line. And the angle between these should be 45 degrees. Nice, and it went right down to the bottom. Finish sketch, turn on the bottom, revolve, profile, go to my axis. I don't want to cut, I want to join those together. And now this part is mostly 3D printable. What do you mean mostly? I don't have any way to eliminate this overhang here and still maintain the look of the overall part. So for this edge, I expect you're going to need support material just to support the outer edge of this. So, yeah. Anyway, so this is a more or less finished part. Maybe we could add a chamfer between these two, because this is going to be relatively weak, and the kids are going to be running around holding it there. So maybe we'll make those walls a little thicker. If I click on this, now let me roll back my timeline here and find where that is. Oh, it's this, this operation right here. I'm going to edit him, and oh, I made it a parameter, wall around straw. So we'll go back. Change the parameter. We'll make the wall around straw instead of 2 extra millimeters on each side. Should be able to, there we go. Straw diameter +6. Make sure that did what we wanted it to do. It does. Yeah, that looks fine. Okay. You know, I realized that I got ahead of myself here, so we're going to do some fun stuff on the timeline while we figure this out. So here, if I group all of these together, let's see, and then I suppress all of these, and I unsuppress the other one, there we go. So this is our snap fit version. Notice it does not have the little straw on the top. That's unfortunate. All right, so let's suppress this feature again. Unsuppress this guy, and I'm also going to, I need to ungroup them. I don't know how to ungroup. Let me right click. Nope. No, it won't let me. So let me Control Z thumb here until we hit the undo button there. So now they're not grouped together. So let's figure out which one of those should be grouped together. So I'm moving the timeline around here. So there's my making the cylinder, threading it. Oh, too far. Go back. There. So these are the operations that are for adding the threads. Now if I suppress adding the threads and I turn back on making the snap fit, now let's see what happens. Okay, that looks like it did what it was supposed to. Combine. Punches a hole in it, that's good. Modifying the top seems to go okay. Oh, but modifying the bottom doesn't. Well, that's crap. All right. So, looks like you need to go back, and this sketch needs to happen earlier in the timeline. I don't know if we can do that or not. It's not earlier in the timeline, but it actually should be part of the group there. It looks like it'll let me edit it. Control Z. Control Z. So I'm going back to Control Z to break everything back out of the group again. Okay, so it's out of the group. Awesome. Come back here. Now I'm going to take my make 3D printable steps, the ones that are impacted here by the thread geometry. I don't know. Maybe can we redo that and let's see what that looks like again. It won't let me redo it. All right, so we'll come up to here, group these together, and then suppress this group. Suppress. Unsuppress this guy. Oh, no, it didn't give me errors. Sweet, it worked. Awesome. Nice. So what I was worried about was that switching back and forth between these would cause the timeline to break because I was referencing some of the geometry there, but it doesn't look like it did. So awesome. Anything more than this is probably gilding the lily. Oh, I do have a line here where these seem to be cutting into each other. Let's see. Where the thread's not cut out of the top? No. Threads are not cut out of the top. So this is my thing here. I expand this. It should have been a combine operation. Why did the combine operation not work? I don't know. Let's go see. Do. Combine, edit feature. Okay. Take and since the threads aren't there, or if the threads there. All right. This is what happens when you mess with suppressing features. It looks like we just hit a bug. This operation was here before, and now it's not. So I moved the threads on the timeline. Now threads are there. My clearance holes are there. That stuff all appears to be working. Great. All right. If I suppress that and I unsuppress the other, great. Now we have a snap fit. Fantastic. That was harder than it should have been. Are these parts 3D printable? I think they are. And you need support material just for the overhang here on the bottom. But that should do it. So let's go see what that looks like over in Prusa Slicer. So utilities, make, and we'll have to do this separately. So I'm going to export the bottom. It's too bad it won't let me select multiple bodies here for export. I have a script for that, but that's a topic for another day. Will let me do it if I bring it in 3MF? No. Oh, too bad. One body per file. Hey, look, 3MF, one body per file. That's what we wanted. Hit OK here, and me hit back to one body per file, and OK. I'm going to ask where I want to save them. Already got my path in here. And this is a lollipop party favor. Save. I'm going to do that again. So let me suppress the snap fit and unsuppress the threads. Make. This is the object. One body per file. OK. Party favor threaded. Save. OK. Let me jump into Prusa Slicer now. One sec. So Prusa Slicer is the slicer I choose to use. If you have another preference, that is completely fine. This is just the one that works for me. So import this now. So File import, folder that it's in, and I want the threaded version, bottom and top. Bring those in, and then bring them in together. So click on one, M to move, him over here, drag him over here, and then this is the place on face tool. The print orientation is right for him. I highlight the other guy. Now the print orientation is right for him. Now if I slice these, I expect it's going to give me a warning about overhangs for the threads. Let's see what we get. Yep. Detected print stability issues. More. Lollipop Party Favors has floating bridge anchors. And the top has floating bridge anchors as well. Aww. So if we pan under here, we can see the areas that it is complaining about. It doesn't. Yeah, it's this area highlighted here in blue. You can see that because it's an overhang perimeter. So I can hide everything else and only see my overhangs. That's really all it's complaining about is those. Yeah. Let me turn all the parts back on, and we can think about how we want to solve that. The easy way to solve it is with support material. I'll come back in here, and we don't want to turn on support for the entire thing. I'll show you what that looks like. So support on build plate only, and slice. And now if let me pan to the side view. Down here you can see that there is oh wait, what? Oh, there's a massive amount of support material inside of this. So you can help that a little bit by using tree supports. So we can go turn that on. So print settings, support material, and change the pattern from grid to organic. Let's go back and look and see what that looks like. Slice, slicing, dramatic pause for effect. Okay. But I still have an absolutely massive amount of support material in there. So I'm spending 30% of my print time printing that support material when all I really needed is on the perimeter. So here's how we'll put it on just the perimeter in Prusa Slicer. So we need to see the underside of the part. And this is paint on supports. I'm going to pick paint on supports. And I want to smart fill on overhangs only. Highlight overhangs by angle, and you can tell it the angles that you care about. So this bottom face here is flat on the print bed, so it's not an overhang. But the one that I care about is this face here. So I've clicked it. Now it's a slightly darker shade of purple, and it will have supports. After you've enabled supports, you need to come back to for support enforcers only. And now I'll switch over to the other part and look at it and see where it thinks it needs supports. So it looks like there's drag it over here and zoom in a little, and a very small edge inside of here that it thinks we need supports for. I think that will be fine without supports, so I'm not going to put them. And I accidentally clicked that, so now if I right click it, I will remove the supports. The right click will block them. Shift right click, shift left click, there it is, shift left, we'll turn them back off. Right. So I hit slice now, and I can zoom out. It's doing its slicing, and now I only have my support material on that outside edge, and that should be pretty easy to pop off. A completely reasonable person might say, that's a lot of support material for a tiny edge. But I come back here and I look at it though. Now I'm only spending 6% of my material in printing the support, so that's fine with me. That doesn't that's fine compared to before when it was 30% of the total print. What else can we do to make this better? If I wanted to mess with those support settings, I could come in here and I could change how aggressively it puts or how far it spaces it out, or what angles on that are. I'm going to leave all of these at the default because I know they work. And at this point, I would send the print job to my printer. The other thing that I want to do though is, where did the part go? Where did it disappear? Oh, because I'm in the paint on support screen. If I come back to the move screen, let's move these a little closer together so the printer spends less time traveling back and forth. Slice it again and send it to the printer. Oh, you know what? I should talk about one more thing. So this up here near the top is a curved surface that we're going to print, and it's parallel to the print there. These sometimes, depending on the amount of curvature you have, don't look great, and you end up with a stair-step effect on these. So if when you print this, you get your stair-step effect and you don't like that, you can help that by changing the layer height. So if I half the layer height, bring everything else over, slice it, the print will take twice as long, but then you'll have less of that stair-step effect. The other thing that you can do is do a thing called adaptive layer height. And with adaptive layer height, it will automatically adjust the layer height as a function of the curvature that it's going through. For this part, I'm not going to turn on adaptive layer height because I would have to do it starting right in here for the bottom curve. So right about here, and then right about here for the top curve. So I would end up having to print these separately and have different amounts of the adaptive layer height. Another thing you might consider is if you want a different appearance for these where it doesn't look like 3D printed layer lines, there's a fuzzy skin option that you can turn on, makes the outside surface of it slightly rough. That tends to help with the stair-step effect as well. I don't really understand why, but it does. So there's some magic in there. Anyway, I hope that helps somebody. It's kind of a long video. And, yeah, cheers. Oh, no, wait, GitHub. I'll publish these up on GitHub and put a link down below to the file.